Okay guys, so like I said, we're talking about definite integrals. This is also called the fundamental theorem of calculus. You know it's important with a big name like that. And what makes it so important is it tells us how to find the area under the curve. And so we're starting off and it says if a function f of x is continuous on the closed interval over a to b, and capital F of x is an antiderivative, also known as an integral, of f of x on the interval AV, then this is going to be true. That if we have a symbol like this where we have numbers here, up to now we've never had numbers here, we always put plus c. Well, now we're going to have the numbers there, which is what makes it a definite integral. And when we do that, we're going to find that antiderivative, and then we're going to substitute in the top number minus, and we're going to substitute in the bottom number, and then we're going to subtract those two. And that's what this is just saying. Find that antiderivative, plug in b, plug in a, and then subtract the second one from the first one. All right, so looking at how this actually works, we've got this integral. Here's our function 3 that we're going to integrate. And so the integral of 3 is 3x. And here's our a and b values. So we have to plug in the top number. So we have to do 3 times 4 is 12 minus 3 times 0 is 0. And so we get 12 for that definite integral. Now, what we actually did there was this. Our function is y equals 3. If I graph that function, that's going to be a horizontal line, y equals 3. We're going to be bounded by the x-axis always. We're also bounded on the left by x equals 0, and on the right by x equals 4. So what we're actually doing when we do this problem is we're finding this area. Well, this is our base, 4. This is our height, 3. 4 times 3 is 12. That's all we're doing is finding the area under the curve, bounded by these values, a and b, and also bounded by the x-axis. Okay? Questions on that? On example 2, we're going to integrate this. So the integral of 4 is 4x. The integral of 2x, I would add 1 to my exponent and then divide by that. Well, 2 over 2 is just going to be 1. And so now I'm going to be having a 2 and a 0. I plug in the top number. 4 times 2 is 8, minus 2 squared is 4, and then minus whatever I get when I plug in 0. 4 times 0 is 0. 0 squared is 0. And so that's, of course, going to give us 4. What am I not putting on here that I have been putting all the rest of the time when we found integrals? Plus c, yeah. We don't put plus c on these because this is not just trying to find the original function. With the indefinite integrals, we were trying to find if this is the derivative, what was the original function. With this type of integration, we're actually trying to find what is the area if this was the original function. So let's look at a picture of this one. Our function would have been y equals 4 minus 2x. What kind of function is that? How would I graph that? Do I know how to graph y equals 4 minus 2x? What kind of shape it would end up being? It's a line, you guys. What's the y-intercept of the line? 4. So I would go up to 4. And then what's the slope of the line? Negative 2. So I'd go down 2 over 1. Down 2 over 1. This is the shape that we're talking about. We're bounded by the x-axis. We're bounded by x equals 2, which is here. Oops, 2 is just here. And 0, which is here. So we're finding this area. Well, this right here is 2. This is 4. What kind of shape is this? Triangle. How do we find the area of a triangle? Base times height divided by 2, 4 times 2 divided by 2, wouldn't we still get 4? Okay, so looking at this visually as well as in an abstract way. All right, let's look at the last one here. So we have a parabola this time. So I'm going to add 1, divide 2x from 3 to 1. So I'm going to plug in 3. 3 cubed is 27, divided by 3 is 9. 2 times 3 is 6, minus, plug in 1, 1/3 minus 2. So now evaluating this, I'm going to have 3 minus 1/3 minus 2 would be negative 1 2/3. So if I have 3 minus negative 1 2/3, that's going to give me 4 2/3 as the answer. So what that is actually finding is when I have my function x squared minus 2, and I look at that function, and I say second, calculate number 7, the lower limit is 1, the upper limit is 3, and it tells me it's 4.6 repeating. Now, something I want to point out, right here, this area right here, that little tiny area, that's actually a negative area. In calculus, here's the way it works. Let's say I have some function. Maybe the function looks like this. This is called a positive area because it's above the x-axis. This would be called a negative area because it's below the x-axis. What would be the net result then if we have this area is positive and this area is negative? What would actually be the total area then from here to here? 0, if it's symmetric about that point. So that's an important thing to remember. Positives above the x-axis, negatives below. All right, so now let's look at the next problem. So we're going to rewrite this. Joe, how would I rewrite that right there? Just getting the x on the top. 2x to the what? And so now integrating this, I would add 1. That gives me negative 2. Okay. And then I have to divide 2 by negative 2. That's going to give me negative 1. And then what's the integral of 1, Madison? X. 3 to 1. I want to simplify this down to negative 1 over x squared minus x. We're going from 3 to 1. I'm going to plug in 3. 3 squared is 9, so I'm going to have negative 1/9 minus 3 minus, plug in 1. 1 squared is 1, so negative 1 minus 1. We can do this without a calculator. Negative 1/9 minus 3 is negative 3 1/9 minus negative 1 minus 1 is negative 2. Okay, I'm going to rewrite this. 3 times 9 is 27 and 1. That's negative 28 over 9. Minus a negative is plus. And I'm going to write this 2. Instead of as 2, I'm going to write it as 18/9. So negative 28/9 plus 18/9 is going to be negative 10/9. And that's what we get for that area. So what does that mean about the curve? Does it mean the whole thing is below the x-axis? It could, but not necessarily, right? It would just mean that more of it's underneath the x-axis. If we feel like we might have done something incorrectly, 2 divided by x squared, x cubed, minus 1, zoom 6. Here's the way it looks. We're trying to calculate that integral from 1 to 3, and so I get negative 1.1111. And in this case, it is all the way, it's always underneath the x-axis, but it wouldn't have to have been. Is that equivalent, negative 1.1 repeated and negative 10/9? If you're not sure about that, figure it out. Negative 10 divided by 9. See if that's equivalent, and it is. Okay? All right, letter B. One thing you want to do, if you can, is get rid of fractions. So over here, to get rid of this fraction, I had to rewrite it as x to the negative 3. But to get rid of my fraction over here, this isn't a variable, so it's not like I can bring it up to the top. When I have a constant like that, I actually want to factor it out. So I'm going to factor a 1 out of the numerator and the 2 out of the denominator. And when I do that, my problem becomes much easier to deal with. So I'm not even going to worry about this fraction until I get to the very, very end of my problem. So I have 1/2. Integrating the v, I'm going to get v squared over 2. Integrating v to the 1/2, I'm going to get v to the 3/2. And then what would I put in front of it? 2/3, good. And then I'm going to evaluate it from 4 to 1. So I'm going to just carry down my 1/2. I'm going to plug in my 4. 4 squared is 16, divided by 2 is 8. Now what does this mean, v to the 3/2? What's the bottom number? Is that the power or the root? That is the what? Root. So we have to take the square root of 4. So what's the square root of 4? 2, cube it, because this is our power, so 2 cubed is 8, times 2 is 16/3. That's what I get when I plug 4 in there. Again, it's the square root of 4, that's 2, cubed is 8, times 2 is 16 over 3. Then I have to do minus what I get when I plug in 1. 1 squared is 1 over 2. This is the square root of 1, that's 1. Cubed is 1, times 2 is 2, so 2/3. So you can get out a calculator now if you want to. I don't care, but I'm just going to do without. So this is going to be 24/3 minus 16/3. This I'm going to get a common denominator for, 3/6 minus 4/6. Just getting a common denominator, bringing down the 1/2. This is going to be 8/3 minus, this is going to be negative 1/6. So this is really going to be 16/6 plus 1/6. And so that's going to be 17/6. 1/2 times 17/6 is 17/8. And that would be our area. Okay? If you're not sure about it, you could even go all the way back up to here. I don't care. You can use your calculator. 0.5 times 8 minus 16/3 minus parentheses 1/2. Got to be careful with the parentheses though. Minus 3/2. Get that answer. Oops, I may have one too many parentheses. Yeah. Get that answer and then math bracket. Oops, what? 17/3? I didn't use enough parentheses. Here's the problem. I needed the whole thing times 1/2. Let me go back there again. See, I needed half of this whole thing, so I needed another set of parentheses. I forgot to put that in at the beginning. So that's what we get. Now math bracket, and we get what? Let me see here. 8 minus 16/3. Oh, this is 17 over 12. 2 times 6 is 12. 17/12. But that's still not right. Does anybody see the mistake here? All right. Well, Well, I'll find the mistake there with the math.